In this video, we are going to prove Thales theorem. This is also called basic proportionality theorem. What is its statement? The statement of this theorem is if a line is drawn parallel, if a line is drawn parallel to one side of a triangle intersecting the other two sides, divides the two sides in the same ratio. Means, let's understand it with the help of a diagram. If a triangle is given to you, and if a triangle is given to you and a line is drawn parallel to one side of the triangle intersecting the one this side and this one side, okay, at 2 points, at point this and at point this, okay, then this line drawn parallel to this line intersecting the other two sides of the triangle divide this side and this side in the same ratio. Means, if triangle ABC is given to you and this is line L which cut the other two sides, which is parallel to the third side BC and intersect the side AB and AC at point P and at point Q, dividing the line, this line AB and this line AB in the same ratio. Means, if it is dividing it in the ratio 2:3, then this ratio will also be 2:3. If this is dividing in the ratio 3:4, then this will also be 3:4. Here, the point to be note is that the ratio will be equal. The ratio will be equal. Okay, so let's prove this. How this happen? Okay, how this happen? So firstly, what you have to do is, and what is the approach we should use to prove this? Okay, so the first thing that you have to write here is given. You should first know what is given to you so that you can proceed to prove this. A triangle ABC is given. ABC is given in which PQ is parallel to side BC of triangle. Okay. This one thing is given to you and you have to prove this. Okay. So before moving forward, I would like to tell you some basic facts. Okay. So let's understand this first, then move to this theorem. Okay. What is the point here? This topic relates to similarity of a triangle. Similarity of a triangle. What do you mean by similar things? Here, a line is similar to this line. A square is similar to another square. This square is similar to this square, right? This circle is similar to this circle. Means two lines are always similar, two squares are always similar, and two circles are always similar. What do you mean by similar? Similarity means the things which looks like same. Which looks like same but not same. Okay. If two things are if two things are equal in all respect, then we call it congruent. But if two things looks alike, look alike, then we call it similar. So this everything is belong to similarity of triangle. Okay. If we talk about the similarity of triangle, what is the basic idea is to prove two triangles are similar. Firstly, two things you have will have to prove. The first one thing is corresponding corresponding angles are equal. The second thing we have to prove is corresponding sides of two triangles are proportional. Okay, so two triangles are similar only if and only if the corresponding angles are equals. So both the criteria are dependent here. Means if you prove the angles are equal, then the triangle will be similar. If you prove the ratio of the sides are proportional, then the triangles will be similar. Okay. So this is the called the basic criteria for the similarity of two triangles. Based upon that, a theorem, a basic proportionality theorem or Thales theorem is developed. And what does this theorem say is, if a line drawn parallel to one side of a triangle intersecting the other two sides of the triangles divide the sides in the same ratio. Okay. So prove this. Prove this. What you have to do first is to do construction. Before that, write to prove. What you have to prove is AP upon PB is equal to AQ upon QC. This is what you have to prove, right? This is what you have to prove. So before proving this, let's do some construction. And what is in this construction is draw P perpendicular to AC and P perpendicular to AC and DQ perpendicular to AB. DQ perpendicular to AB. Also join BQ and PC. This one. Join BQ and join this PC. After joining this, what you have to do here is we have to prove. Okay, you have to prove. So now let's look into the triangle APQ. In triangle APQ, if you find area of triangle APQ, what you will get is 1 by 2 into base into height. So what is base here and what is height here? In triangle APQ, 1 by 2 base into height. So here 1 by 2 is there. In this triangle, what is the base? This is the base because this is perpendicular and this is perpendicular. For this triangle, this is base and this is height, right? So here you can see this is base and this is height, right? And you have to prove this one. So base is AP, base is AP, and height is DQ. So height is DQ. Height is DQ. Number this as 1. Okay. Now we will move to, let's copy this figure so that it will be in front of us. We are going to prove this here. Okay. So here is the theorem. We found area of this triangle. Again, if you have to find the area of the triangle APQ, what would be our other approach is 1 by 2 into AQ into PE. How? In this triangle, this is the base, this is the height, right? This is the base and this is the height. And because we have drawn P parallel to AQ. Yes? So we can find the area of this triangle in this way. So this is our 2. Here we have found the area of triangle APQ in the 2 different way. Area of triangle APQ in the 2 different way, right? The first one was area of triangle APQ was 1 by 2 into AP into DQ. So from these 2 equations 1 and 2, if you divide 1 by 2, what you will get is 1 by 2 AQ into PE is equal to 1 by 2 into AP into DQ. So this one will get cancelled out, and what we found is PE upon DQ is equal to AP upon AQ, right? Name this as 3. Now what we have to do is look at this triangle and at this triangle. We have to find its area again. You have to find its area again. Okay, so let's find this one. So area of triangle BPQ. Area of triangle BPQ. What is its area? What is the area of triangle BPQ? So area of triangle BPQ is 1 by 2 into base is BP and height you can see here. आपको लगता होगा कि इसका height कहाँ से मिलेगा, right? If you have to find its area, this is the base and this is the height. This is the base and this is the height. So here we have, this is BP into DQ. Okay, name this as 4. Also area of triangle CQP is equal to 1 by 2 into what is its base is QC, And what is height is, here its height is, this is the triangle and this is its height, right? So here we have, this is QC into PE, PE, okay? Name this 5. Now, one more thing that, one more concept that is used here is, this triangle and this triangle, this triangle and this triangle will have equal area. Now how? Because in class 9th, in the earlier classes, you have learned that triangle on the same base and between the same parallel have equal area. What is the theorem? One more concept that you have to learn here is, because here we have use of it. Two triangles, two triangles drawn on the same base and between the same parallel will have equal area. If two triangles are given to you, right? If two triangles are given to you, then that is drawn on the same base and same parallel will have equal area, right? So we will use this concept here. You can see this figure. What you can observe is, this triangle and this triangle is drawn between the parallel lines, and this one is its base, which is common to this triangle and this triangle. So the triangle BPQ and triangle CQP will have same area. Yes sir, this will have same area. Means, therefore, using this concept, area of triangle BPQ is equal to area of triangle CQP. ठीक है? So both the triangles are equal. Both triangles are equal. If both the triangles are equal, what does this mean? You can replace this one. Firstly divide this one and this one. Okay, what you get? So look at this first. Divide 4 by 5. What you get is area of triangle BPQ by area of triangle CQP is equal to BP into DQ upon QC into P, right? So this one thing that you get here, and we know keep triangle of BP, area of triangle BPQ and CQP are equal. It means this will get cancelled out and we get as 1. So QC into P is equal to BP into DQ, and from here we'll get DQ. If this will go there, this will come there here, then what will get is DQ upon P is equal to QC upon BP. So this is what we got here. Name this as 6, right? Now here you can see from this one and this one. Here we have PE upon DQ is equal to AP upon AQ, and here we have DQ upon P is equal to QC upon BP. So let's do something. What will we do? What will you do? Here, take reciprocal of it and get PE upon DQ is equal to BP upon QC. So from this one, what we observe is both the ratio from 3, this one ratio, and in this ratio we have same thing in the LHS, So what we can conclude from here is AP upon AQ is equal to, from 3 and 7, what we can conclude is AP upon AQ, AP upon AQ is equal to BP upon QC. So this is what we get. This is what we get from here. Okay? And this is what we have to prove. What we have, where we have started. We have started from here. We have given a triangle in which PQ is drawn parallel to the side BC, and we have to prove AP upon BQ is equal to AQ upon QC. Right? So this is what we have to prove here. This is what we have to prove. This is what we have to prove. So starting from this, we have proved this one. Huh? So let's take a recap of it. We have done a construction in which PE is drawn parallel to PE is drawn perpendicular to the side AC, and DQ is drawn perpendicular to the side AB. Okay, and due to this, we proceeded forward. Okay, we have found this area of triangle in the two different way, taken the ratio, cancel out the common things, and we got as AP. We got as, here you can see, you get as PE upon DQ. PE upon DQ is equal to AP upon AQ. Okay, so this is what we get. Again, we found the area of this triangle, and in this triangle, and taken its ratio, and we have used the theorem that triangle on the same base and between the same parallel have equal area. Okay, and using that one thing, what we have concluded that DQ upon P is equal to QC upon BP. And at the end, we have calculated from the 3 and 4. What is 3? What is 3? The 3 is PE upon DQ is equal to AP upon AQ, right? And here we have PE upon DQ is equal to BP upon QC. So both are same. LHS is same, therefore RHS will be same, right? Left hand side is same as the right hand side. Okay, so in this way we have proved the basic proportionality theorem. I hope you all have understood the theorem very well. Thank you for watching. Stay connected with me.